Software Quality Assurance Crash Course. Classification. Overview. Software testing classification is a systematic categorization of the software testing types according to their purpose criteria. The perception of classification allows making informed decisions and contribute to delivering reliable software products. The main goals of the software testing classification include comprehensive segmentation, testing strategy tailoring, efficient resource allocation, forcible risk mitigation, and responsive quality assurance. The choice of the testing type depends on such factors like system scope, development stage, project budget, and software significance. Requirement analysis stage classified. Requirement analysis is the stage to determine the very approach for the documentation strategy of the upcoming development and testing processes. There are two major testing types crucial for the requirement analysis stage: casual testing and formal testing. Casual testing is a type of software testing performed without any dedicated planning, documentation, and procedures. There are three major types of casual testing: ad hoc testing, intuitional testing, and exploratory testing. Ad hoc testing is the least formal type of casual testing, also called random testing. Ad hoc tests are only run once, unless a bug is discovered, and since the tests are not documented, the found defects are difficult to reproduce. The strength of ad hoc testing is in its applicability during the earliest stages of development lifecycle, so the evident bugs are found quickly. Intuitional testing is a type of casual testing based on the prior testing experience and expertise, which is often called error guessing. Error guessing has no explicit testing rules and depends on the situation entirely. It is solely determined by the past experience and intuition of a quality assurance engineer who may possibly know the problem areas which commonly invoke the software failures. Exploratory testing is a type of casual testing performed as a process of simultaneous learning, test design, and test execution. While the software is being tested, the tester learns things that together with experience and creativity generates new good tests to run. Checklist is the only artifact used to structurize the exploratory testing in order not to waste time repeating the same tests. Formal testing is a type of software testing performed with a proper planning, documentation, and procedures. It is carried out with meticulous test cases documentation and systematically adhere to the software testing lifecycle. Formal testing is more expensive due to the outlays for the test case preparation, personnel training, and documentation authoring. Formal testing has three primary documentation origins: user stories, business scenarios, and software requirements specification. Respectively, there are three major types of formal testing: story-based testing, scenario-based testing, and specification-based testing. In practice, casual testing tends to be replaced by formal testing for the sake of its greater efficiency. Planning stage classified. Planning is the stage to determine the very testing approach for the next software development life cycle. There are two major testing types crucial for the planning stage: static testing and dynamic testing. Static testing is a type of formal testing performed without the software code execution. For the reason, static testing is also called documentation testing, non-execution testing, verification testing, and testing review. The most important statically tested documents include user stories, business scenarios or SRS, design specifications, test plan and test cases, source code and test scripts, and user manuals and help. Static testing, requiring no software run, allows catching crucial bugs and ambiguities on the earliest stages of the development. The earlier logic mistakes and flaws are found, the lesser the cost of their revision and the straighter the process of software development. But in practice, static testing tends to be replaced by dynamic testing. Dynamic testing is a type of formal testing performed with the software code execution. It allows validating the software functional behavior, memory, processes, and overall performance in dynamics. That's why dynamic testing is also called execution testing or validation testing. Dynamic testing focuses on evaluating the runtime behavior of the software code and observing its behavior under various conditions. It aims to ensure that the software functions correctly during and after installation and implies actual output correlation with the expected one. Dynamic testing may begin before the software is ready. Certain units or components may be tested dynamically using stubs, drivers, or debuggers. Design stage classified. Design is the stage which allows acquiring the first operable prototype or minimum viable product. There are two major software testing types during the design stage: passive testing and active testing. Passive testing is a type of dynamic testing performed through the code execution with no user interactions with the software. Passive testing means verifying the system behavior through the offline runtime verification, log analysis, and stack trace inspection. Active testing is a type of dynamic testing performed through the code execution along with user interactions with the software. Active testing is dedicated to evaluate the robustness, reliability, and optimal performance of the software in dynamic environments. In practice, passive testing tends to be replaced by active testing. Development stage classified. Development is the stage which provides both executable and testable builds of a target software. There are three testing types performed during the development stage: white box testing, black box testing, and gray box testing. White box testing is a type of active testing performed with the knowledge of software code, internal structure, and implementation details. The term refers to the see-through box concept, which symbolizes the ability to see through the software's outer shell into its inner state. White box testing requires primarily software developers or developers in test, making the type of testing more expensive. Black box testing is a type of active testing performed with no knowledge of software code, internal structure, and implementation details. The term symbolizes the inability to see the inner software implementation so that only the tester's experience can be applied. Black box testing requires primarily manual quality assurance engineers who can better imitate the external behavior of terminal users. Gray box testing is a type of active testing performed with a partial lore of software code, internal structure, and implementation details. The term infers that the approach is a combination of both black box and white box testing. In practice, white box testing tends to be replaced by black box testing due to its greater affordability. There are 5 white box testing levels, depending on the tested scope: unit testing, component testing, module testing, integration testing, and system testing. Unit testing is the minor level of white box testing, typically performed by developers, which spots on testing the individual units in isolation. Component testing is the type of white box testing performed on a compound feature derived from the independent units coalition in isolation. Module testing is the type of white box testing which focuses on testing the independent modules made of grouped components in isolation. Integration testing is a level of white box testing performed on a set of modules joined in a subsystem entity to verify the combined operability. System testing is a level of white box testing conducted on the integrated software to evaluate its compliance with the requirements specified. There are also 5 black box testing levels, depending on the tested scope: smoke testing, sanity testing, critical path testing, extended testing, and exhaustive testing. Smoke testing is a level of black box testing performed to reveal evident defects severe enough to reject a build promoted for further verification. Sanity testing is a level of black box testing carried out to quickly evaluate the software operability against the basic set of verifications. Critical path testing is a level of black box testing to analyze the functionality most commonly employed by the majority of software users. Extended testing is a level of black box testing performed to explore all declared functionality specified in software requirement specification. Exhaustive testing is a level of black box testing performed to confirm that the software functions correctly under every possible situation. While exhaustive testing, also called complete testing, isn't achievable, diligent testing helps create robust applications with minimal defects. Testing stage classified. Testing is the stage of repetitive software build validations to fetch it to the state of a release candidate. There are 2 testing types performed during the testing stage: operational testing and functional testing. Operational testing is a type of black box testing performed to validate non-functional aspects of the software. Non-functional aspects are those that reflect the quality of the product, particularly in the context of the suitability perspective of its users. It refers to the aspects not related to a specific software function: performance, usability, reliability, scalability, security, etc. Operational testing is designed to verify the software readiness as per non-functional parameters which are never addressed by functional testing. Functional testing is a type of black box testing performed to validate the software against its functional requirements and specifications. Functional testing is to verify the software actions by providing an input and estimating the output against the documented conditions. In practice, operational testing tends to be replaced by functional testing due to its first-grade importance. There are 4 major types of operational testing: installation testing, usability testing, payload testing, and security testing. Directionality is the main property of functional testing. There are 2 major types of functional testing: positive testing and negative testing. Positive testing is a type of functional testing performed on a software by providing valid and proper data as input. Positive testing verifies whether the software behaves as expected with positive and awaited user inputs or not. Positive testing should be followed by negative one because defects found through the positive tests exclude the very necessity of further testing. Negative testing is a type of functional testing performed on a software by providing invalid or improper data as input. Negative testing verifies whether the software behaves as expected with negative or unwanted user inputs or not. In other words, a software may, and actually should, work correctly under improper contexts, that is during negative tests are run. Deployment stage classified. Deployment is the stage of release candidate build validations to ensure its approval and further rendering to the client. There are 2 testing types performed during the deployment stage: feature testing and regression testing. Feature testing is a type of functional testing performed to verify the code or environment amendments comply with the software requirements. The goal of feature testing is to ensure that the features function as expected, introduce no defects, and maintain overall software quality. Regression testing is a type of functional testing performed to verify the code or environment amendments retain the previously achieved quality. Regression testing implies that already developed tests are re-executed to verify the influence of changes on the functionality existed before. Maintenance stage classified. Maintenance is the stage to enhance the software test coverage to assure its higher quality prior to the next cycle of development. There are 2 types of testing performed during the maintenance stage: manual testing and automated testing. Manual testing is a type of regression testing executed manually. Manual testing means all the essential software feature verifications and test report generation are performed without the automated testing tools. Automated testing is a type of regression testing executed automatically. Automated testing implies the use of appropriate automation tools to develop, enhance, and execute the test scripts to validate the software. In practice, manual testing tends to be replaced by automated testing to keep the software test coverage as high as possible.